Hello and welcome to Algebra 1 Test 9 Study Guide. We're here to walk you through 10 questions that are going to be very similar to the 10 questions that are on the test that you're here to retake. The idea is we'll go through some problems to reteach this stuff to you, or maybe you didn't even understand it to begin with. So hopefully by the end of this video and working through these problems, you'll feel good and feel ready to retake the test so that we can help you raise your grade, because that's what this is really all about. So it's not punishment, not trying to torture you didn't do anything wrong, just here to help you raise your grade. My name is Mr. Sipple, and I'll be walking you through the video and through the 10 questions as we mentioned. Starting off, let's go ahead and just make sure we got our name on our paper. So top right corner, go ahead and write your name. And because some of you are coming from different teachers, if you'll write your teacher's name so that we make sure that we get you credit for being here today. And if this is your first time with us, just in general, to kind of lay out the format of how this is going to work, is that you'll notice on the paper here there's 3 columns. The first column is where I'm going to work through an example problem to show you how to do it. Then I'll tell you to pause the video and then have you work through the problem that's in the middle column and then the problem that's on the right side over there. You'll notice that going across, like 1.1, 1.2, 1.3, they're really the same problem, just with different numbers. So the idea is I'll show you one how to do it, and then you try to on your own to get a little practice to make sure that you understand how to do it. Try to do as much of this video and the work in it on your own. If you just copy and watch what I'm doing, it's probably not going to do you all that much of good. So you really want to try to be doing this as much as you can on your own. And again, don't just mindlessly zone out and just stare at the screen. If you're having problems with any one of these problems, you're stuck, please, I'm in the room here with you, so ask. I'll come over and help you out, because I don't want you to just sit there and think that the only help that you get is through the video, because that's why we have you do it here at school, so I can help you with it. Alright, so let's go ahead and get started. So you don't have to write this down. I just wanted to kind of give you a preview of what we're going to be looking at. The learning objective really here is to simplify rational expressions. That word simplify just means to reduce or to make smaller, right? So what we're really talking about doing is we're just talking about reducing fractions. What kind of fractions? Well, these kind of fractions are called rational expressions. I call them funky fractions. The reason why I call them funky fractions is because it's a fraction. And when I say fraction, you probably think of something that looks like that, like 2 over 6, 1/2, 1/3, something like that. But this guy here, he's a fraction too. It's just that there's a little bit more going on, right? So it's a fraction that not only has numbers, as this fraction does, but it also has variables and it also has exponents. But just like you'd want to try to reduce this fraction, so for instance 2 over 6, right, which we could divide top and bottom by to get 1/3. So in the same way that you'd want to reduce a fraction like that, we're going to do the same thing with this fraction over here. The only difference is that in addition to having numbers, we've got some variables and we've got some exponents. But that's all right. We're going to take a look at how we would go about reducing a fraction that looks like that. But anyways, just keep that in mind. We're just working with fractions. They're just fractions that look a little different because there's some numbers, variables, and exponents in there. Alright, so let's go ahead and take a look at the first one. So this is our first fraction. And what we want to do is we just want to reduce this fraction. Now what you may want to thinking about is, well, what if this just said 2 over 8? Right? So what if that was all that I had to reduce? Well, if the fraction was just 2 over 8, let me kind of go to the side here. You know, then I would say, oh, okay, well, I can divide top and bottom by 2, and then that fraction would end up being 1 over 4. Well, in the same way, that's going to be true here, is that the fraction is going to be 1 over 4. But then there's not just numbers there. There's also A's, and there's B's, and there's C's. So that's why I got to figure out what to do with that. Now, let me show you kind of the long way of looking at this, and then we're gonna use a shortcut way of doing this. Let's just pretend, and again, we're going to kind of just isolate this for a second. Let's just pretend that the problem was a squared over a to the 5th. So I'm just going to look at this one part of the fraction. Well, you know, a squared means a times a, right? Because the exponent tells you how many times to write it out. A to the 5th would mean a times a times a times a, right? So that 5 means I would write it out 5 times. And then because the fraction is another way of saying division, what I would be doing is I would cancel those a's, and then I'd say, well, what do I have left over? Well, I've got 1, 2, 3 a's left over, and they're left over on the bottom. So that would be a cubed. Let's talk about the b's, for instance, right? So if I wanted to say the b's, that says b over b. Well, b over b, those would just cancel each other out, right? And you just would have 1 over 1, which would really just be 1. And then the c's, if you looked at the c's, that says c to the 6th power. And these are actually going to end up being our shortcuts here that I'm going to point out in a second. So if you took the c's, for instance, and you wrote that out, so for instance, c to the 6th power, which would be 6 of them, right? Let's say c to the 6 over c to the 5th. So that would be c times c times c times c times c times c. 1, 2, 3, 4, 5, 6. All right. And then 5 of them on the bottom. And let's see, 1, 2, 3, 4, 5. And then we would cancel those out. And then we'd say, well, how many do we have left over? Well, we've got 1 left over, and it's on the top. So that c would be left over on the top. Now, 1 times c is just c, so I could just say c over 4a cubed. And that's what that fraction would be reduced. Now, so look at what I did, though, is I wrote all of this stuff out, and you're like, oh, wow, really? Do we have to do that for every single one of them? Well, the thing is that, no, you really wouldn't want to do that, because if we just kind of pretended for a second, if I said, I'm just going to kind of make something up separate here on the side, you know, if I said, what's a to the 100 over a to the 80, well, you know, you really wouldn't want to write that out 100 times and then write that out 80 times and then cancel. So let's look for a shortcut, right? So let's look back here what happened. 2 and 5, and I ended up with a 3 in my answer. Oh, okay. Well, 5 minus 2 is 3. And then the leftovers, and this is what I have right here, the leftover variables go to the side that has more. So there's more a's on the bottom, so that's why the leftover a's went to the bottom. Now, there was no leftovers here because the b's canceled each other out. 6 minus 5 is 1, so I have 1c left over. Not sure why that looks like a 6. There should be a c. So I have 1c left over, and that 1c left over was on the top, so that's where the c went to the top, right? So I showed you this write it out method. You know, if this is really kind of more of a middle schoolish way of looking at it, but it's also a way for you to get the understanding of what we're doing, but it's really too much work to do it this way, or more work than maybe what we'd want to do. So we're going to use a shortcut, and that shortcut is this, and make sure you do write this down, is that we're going to subtract the exponents. So subtract the exponents. You don't have to write it out like this. The shortcut is to subtract the exponents. And if you have leftovers, so the leftovers go to the side that has more. And that's what your fraction would be reduced. All right, well, take a moment, go ahead and pause now, and what I'd like you to do is try to do 1.2 in the middle, which is exactly as similar to this one, and then 1.3 on the right side. Okay, so you should have had opportunity to try 1.2 and 1.3. What I'll do for you is I'll show you what the answer is. So 1.2, the answer is b squared over 2c cubed. If you got that one correct, great. Let's go ahead and check the next one. If you did not get this as your answer, what you want to do is pause here, see if you can figure out, now that you know what the answer is, see if you can figure out your mistake, see if you can see where you went wrong. If you're still not sure what went wrong, then this is where you need to just ask me, and I will come over in there and I'll help you. Let's check 1.3. So it should have had b to the 4th over 3a to the 4th. Again, if you got it, great. Let's go ahead and go on to the next one. If you didn't get that one, try it first, right? Try to see if you can figure out your mistake first. If not, again, please ask me for some help. All right, well, let's go ahead and move on to the second one. Okay, so what you'll notice that's a little bit different about this fraction is that in the last fraction, it was just one term on the top and one term on the bottom. What do I mean by that? Well, what you notice here is that there's two terms. See, the plus or minus sign kind of almost acts like a comma in language. You know, think about in English, when you write out a list of things, you use commas. Well, in math, we separate things by plus or minus signs. So this says 6x squared, which is one term, minus 15x, which is another term. Well, what happens is that what I cannot do, and don't write this down because it's not right, I can't just start dividing, you know, these numbers and say, oh, I'm going to cancel the x's, and I can't start doing that because those are a part of a group. And so groups have to be factored first. So what do I mean by factoring? Factoring is the process of going back to say, what did it look like before it got multiplied? What I mean by that is that if we took 6x squared minus 15x, factoring is the process of going back. That's why I got this rewind button down there in the bottom right-hand corner. It's going back to say there was something on the outside that got multiplied or distributed to two things on the inside. What I want to know is, well, what was on the outside and then what must have been on the inside. Well, how you go about doing that is that you first ask yourself a number. Alright, so you say, well, what number goes into 6 and 15? Well, both of those numbers are divisible by 3. So there must have been a 3 on the outside. And then you say, okay, and what we're finding here, by the way, is our greatest common factor. And then you say, well, do they have any variables in common? Well, they both have an x in common, so there must have been a 3x on the outside. And then what you say is, okay, let's see if we can solve the mystery here. I would say 3x times what would give me 6x squared? Well, 3 times 2 is what must have given me the 6, and then x times x would give me the x squared. And then we'll do the same thing for the second term. So we'll go back and say 3x times what makes a negative 15x? Well, 3 times a negative 5 is what would give us the negative 15. And we actually already have 3x times negative 5. That already gives us the x, so we're good there. Right? So factoring, again, factoring is this idea right here. Factoring. I really want you to get this visual of hitting the rewind button. You're just going back to say, what did it look like before something got distributed? What's nice about factoring is you can always check your answer, because if you said 3x times 2x, that's 6x squared. And then if you said 3x times negative 5, that's negative 15x. Right? So you can always check to see if you got it correctly or not. All right, let's try to factor it on the bottom then. So again, we're starting with the idea of what's the biggest number that goes into both of those. Well, 9 goes into both of those numbers. And then you say, how many letters do they have in common? Well, they have an x squared in common. And let me show you maybe the visual. I'll kind of go to the side and do some scratch work here. Because see, really what I'm doing here is just mental math. And so if you're looking at that and you're not quite sure where that's coming from, well, let me show you kind of visually what we're doing here. So let's just take 27x cubed plus 9x squared. So if I broke apart 27, what makes 27 is 9 times 3, and x cubed would be x times x plus 9x squared, which would be 9 times x. So what I'm looking for is I'm looking for everything that they have in common. So they have a 9 in common, and it looks like they have a pair of x's. But only a pair, because you see that, yeah, the left side has an x, but this right side doesn't have another x. So I can only say that they have two x's in common. So you notice that what I circled, 9x squared, that's what my greatest common factor is. Now, what would be left over on the inside? We'll look at what's left over down here. What's left over down here is 3x plus, oh, and there's nothing else over there, right? So what would that mean? Well, that would have to be 3x plus 1. And again, I can check, because if I said 9x squared times 3x, that gives me 27x cubed. 9x squared times 1, which gives me 9x squared. Okay. So now now what I just did down here on the bottom, that's not something that's not work that you necessarily have to show. This was just a little bit of scratch work to show you how we're getting this part, right? So this is really kind of doing it mentally, but if you feel more comfortable doing it this way, then you certainly can do that as well. All right, now what you notice up here, 2x minus 5, 3x plus 1, okay, so we've got it factored. What I notice now is that if you look at the terms on the outside, I can cancel those because they're no longer a part of the group, right? They're an individual. There's no plus or minus sign separating 3x and 9x squared. So I use the analogy of a Coke. You go to the store, if it's a 12-pack of Coke, you got to buy the whole 12-pack. You can't go in there and just rip out one of the Cokes. So you have to cancel as a group. So these groups are not the same, so I can't cancel them. But these guys are not a part of a group, so I can cancel that. So this is where it becomes very similar to what we just did on the last one, which is you're going to divide the coefficients, right, the numbers in front, and then just subtract the exponents. So 3 divided by 3 would just be 1, which 1 times anything would just be itself. And then on the bottom, 9 divided by 3 would be 3. And if you talked about canceling the x's, if you canceled an x from here, then there would only be one x left over here. So that's where we would get 3x. And then what's inside the parentheses would be left over, 3x plus 1. So we had to factor it first, and then we separated it into two things. We had groups, and then we had individual terms. The groups didn't match, so we couldn't cancel them. But the individual terms did have things that we could cancel. All right, so go ahead and pause the video now and try 2, 2 and 2, 3 on the right side. All right, so let's check in with you. 2, 2 should have got x times 3x minus 2, and that's over 2 times 2x plus 3. So if you did not get that correct, go back, double check your work. Excuse me. See if you can find your mistake. Otherwise, if you're not sure where you went wrong, ask for help. And 2, 3 on the right side should have got x times 3x plus 5, and then 2 times 4x minus 2. Once again, if you got it correct, let's go ahead and move on to the next problem. If you did not, always try to figure out first on your own and see if you can figure out your mistake. Because a lot of times, even making a mistake, a lot of learning comes in that process of trying to figure out the mistake. Otherwise, ask for some help. All right, so let's go ahead and move on to 3.1. So now this is another fraction. Again, keep in mind here, right? Rational expressions, these are just fractions. We're just trying to reduce these fractions. What's different about this is that there's 3 terms, 1, 2, 3. That's what we call a trinomial. So like tricycle has 3 wheels, trinomial means 3 terms, 1, 2, 3. So what happens is, as we said in that last one, is that if it's a group, which something that has 3 terms is a group, what I cannot do is I can't just say, oh, I'm going to cancel the x squareds, and 3 goes into 6 2 times, right? So cancel the x's. Can't do that, can't do that. Remember, so it's a package deal, so you have to be able to cancel them as groups. So what I would need to do is I would need to factor first. So when you factor a trinomial, what it gets, the pattern on this is that what a trinomial looked like before it was a trinomial was 2 binomials, so 2 groups of 2. So again, here's that rewind button again. We're doing the same thing. We're saying before this got multiplied out, right? Because this got multiplied out. Whatever this was gives us 3x squared minus 8x minus 3. So what we're trying to do is work backwards. Let me hit the rewind button here. So what we're trying to do is we're trying to work backwards and figure out what did that actually look like. Well, we have a little tool that helps us doing this, and hopefully this should be familiar to you. If you look down there at the bottom right, we call that the big X or the Xbox method, diamond. It's got a bunch of different names. But the idea is that it's a tool that helps you figure out how to factor, how to go backwards. All right, so the way that this thing works is that you take A times C, that goes on the top, B goes on the bottom. Now, what do we mean by a times c? Well, there's your a, b, and your c. So the numbers in the trinomial, it goes in order. So the first number is a, second number is b, third number is c. So a times c would be 3 times negative 3, which would be a negative 9. And then on the bottom, I've got b, which is a negative 8. And by the way, I'm doing one at a time. So I'm just doing the numerator right now. So I'm just doing the numerator of the fraction. And what I'm looking for here is I'm looking for two numbers that multiply to the top. We want those same two numbers to add up to the bottom. So if you think about what multiplies to 9, first thing that comes to my mind is 3 and 3, but that doesn't add up to 8. Oh, okay, so how about 9 and 1? But it's negative, so that means that one of these would have to be negative. So then I look down and I say, well, that number is negative, so that must mean that the bigger number is negative. And I can test that out, because if I said negative 9 times, or negative 9 plus 1, I'd get a negative 8. Okay, so that works. So then what happens, I put those back in parentheses. So I've got x minus 9, and then I've got x plus 1. And then there's one other thing that you have to do with when you're doing the big X here, is that you have to always divide by a, whatever the a is, which in this case the a is 3. And again, hopefully this is familiar to you. You saw factoring. Factoring was actually, the test before this was all questions like this. You've subsequently seen factoring with quadratics, so hopefully I'm not showing you anything that you hadn't seen before. 9 divided by 3 would be x minus 3, so what we say is that if you can't divide it, slide it. What we mean by that is that 9 divided by 3, okay, I can do that, that's 3. And then 1 divided by 3, though, that would be a fraction. So I'm not going to end up dividing that, so I slide it back in front of the variable. So that actually would become 3x plus 1. Okay. Now, that's not my answer. That's just what the top part of that fraction is. So see, what I just did here is I just did the numerator. So let me separate this. So this was the top of the fraction. This was the numerator where I did this, 3x squared minus 8x minus 3. Okay. So now what I needed to do is now I need to do the bottom part of the fraction. So let me take what I got. I got x minus 3 and 3x plus 1. And now I just need to do the same thing, but I just got to do it for the bottom. So let me take the bottom of the fraction, which is x squared minus x minus 6, and I want to do the same thing. All right, a, b, and c. Well, let's label that out, see what we come up with. So as far as my a and my b and my c, so my a is 1, my b is a negative 1, and c is a negative 6. So see, if you don't see numbers there, you just got to write those in. So that's really a 1. So a times c, and then b. So you'd have a negative 6 on the top, and then on the bottom a negative 1. So looking for two numbers that multiply to negative 6 that add up to negative 1. Thinking 3 and 2, and then you ask yourself, okay, well, does it add or subtract to the number that's on the bottom? 3 plus 2 is 5, but 3 minus 2 is 1. And then I've just got to figure out what the deal is with the sign. So I know it's going to be 3 and 2. There's more negatives on the bottom, so that means there must have been more negatives to begin with. So that would be a negative 3. All right, so let's put that in parentheses. So x minus 3 and x plus 2. And we got to divide by a, which our a for the bottom part of the fraction was 1. So let's divide by 1. What you notice on this one, when you divide by 1, it ends up just staying the same. So that's kind of nice, because that whole thing of, divide it, slide it, didn't really have to do any extra work there. So that would be x plus 2. All right, so I'm going to fill that in. So I've got x minus 3, and then I've got x plus 2. Now, so what I'm looking to do at this point is I'm looking to cancel like groups. As I said, it's a package deal. Can't go in there and just rip out one of the x's. You have to be able to take it as a group. So I would cancel a group of x minus 3 and a group of x minus 3. However, 3x plus 1 is not the same thing as x plus 2, so then I would just leave it as it is. So the final answer there would be 3x plus 1 over x plus 2. Right? And that would be as far as we could reduce that problem. All right, well, go ahead and pause now. Try number 3, 2 in the middle, and try 3, 3 on the right side. And then we'll be back in a second with you to check the answers. All right, so let's see what you got for 3, 2. So should have got 3x minus 2 over x minus 4. If you didn't get that, see if you can figure out where you went wrong. If you're not able to figure that out, just ask. 3, 3 should have got 3x plus 5 over x plus 3. And again, once again, try, see how much you can figure out on your own. So see if you're able to figure it out. I'll tell you right now, a lot of mistakes that get made with this is that, and just kind of went back there for a second, is, in the factoring, right? So you probably, if you had difficulties with it, was probably somewhere in here with the factoring. Once you get to the end and you're just slashing stuff that looks the same, that's not the hard part. So I think the challenge will probably be, did you get these numbers right? Did you get the sign right? So make sure you're just looking out for those little things. All right. Otherwise, we will go ahead and move on to the fourth problem. All right. So got another fraction that we need to reduce here. They are a group. So it's a group of 2 and a group of 2. So I know that they must be factored first. So I know that I need to hit the rewind button over there. So what I know is that I know that there must have been something on the outside that got distributed or got multiplied to 2 things on the inside. I just want to figure out what those things are. By the way, which we should mention here is that in regards to the big X, the question of, well, how do I know when to use the big X? We use the big X for trinomials, right? So let me just go back to number 3 real quick. So again, 1, 2, 3. So that's your cue, or that's how you would know when it's a big X problem, when there's 3 terms. Otherwise, what you're looking for is it in 99% of the cases, if it's just 2 terms, then you're just looking for the greatest common factor. So you're just looking to see what was on the outside. All right, so what goes into 2 and 32? Well, that would be 2. This guy's got an x squared, but this one doesn't, so there's no letter in common, no variable in common. And then I'd say, well, 2 times what makes 2x squared? Well, that would have to be an x squared. And then 2 times what makes negative 32? Well, that would have to be a negative 16. Let's check it out on the bottom. What goes into 2 and 8? Well, 2. And then I say 2 times what makes 2x? Well, that would have to be an x. And then 2 times what makes 8? That would have to be a 4. And again, if you want a little visual on what's happening there, because really what we're doing is we're factoring out that greatest common factor mentally. So I hope that you're okay with that. If you're not, I would give you another way to maybe think of this, which is that you could take 2x plus 8, and this is kind of if you were going to write it out, so maybe for those that are a little bit more visual, is that I would write this out and I'd say, well, 2x really is 2 times x plus 8, which is 4 times 2. And then what I look at is I say, well, what do they have in common? Well, they have a 2 in common, so that's how we ended up with the 2 on the outside. And then what they have left over is this part in the middle, right? This x plus 4. So that's where the x plus 4 came from right there. So that's one way for those that are maybe a little more visual and you need to kind of see it that way. That's another way that you can take a look at it. All right, well, so I can see that the 2's cancel. And I see, well, those aren't the same group, so there's nothing I can cancel there. So you might think we're almost done. But x squared minus 16 is, I told you just a second ago that diamond problems are always trinomials, have 3 terms. X squared minus 16 is kind of the one exception to that whole thing. And the reason being is because x squared minus 16 is what we call a difference of squares. So it actually is, so this is the one exception to big X problems always having 3 terms, is that what happens here is in terms of your A, B, and your C, your A is equal to 1, your C is equal to negative 16. What's missing is the BX term. So look over here on the right side. So the bx term is missing. And the reason why it's missing is because the b is actually equal to 0. So that's why there's only two terms, is because the middle term is actually equal to 0. Now it works the same. You're looking for two numbers that multiply to the top that add up to the bottom, which would be negative 4 and positive 4, right? Because they would have to add up to 0. Now, so difference of squares, how do you recognize it's this kind of pattern? By the way, why is it called the difference of squares? Well, squares, if you look at the square root of 16 is 4. So this number will always be a perfect square. So if it said x squared minus 11, then that's not a difference of squares. Difference, because this will always be subtraction. And maybe another way to think of it is that if you look at the numbers, the factors, it's the same number, just one is a plus and one is a minus. So this would be 2 times x plus 4 times x minus 4 over 2 times x plus 4. So from that point now, we can go ahead and slash it out. So we say, well, the 2's cancel, and then x plus 4 cancels. And then actually, the only thing that we have left over is just x minus 4. Okay. And hopefully by now you've seen the difference of squares, because this is something that will come up quite frequently. So it'll be something you see again. Difference of squares. We saw it in the last test with factoring. You'll see it with quadratics as well. So a difference of squares. So we'll see more of that pattern. All right, so go ahead and pause now. And 4.2 and 4.3 both have difference of squares problems. So when you get right here, it'll be a difference of squares. So try 4.2 and 4.3. All right, so let's see what you got with 4.2. So 4.2 in the middle should have got x minus 3. And for 4.3, on the right side, you should have got x minus 1. So again, if you did not get the correct answer for either one of those, 4.2 was x minus 3, 4.3 is x minus 1. If you did not get the correct answer for either one of those, see if you can figure out where you went wrong. If not, ask. Otherwise, we will move on. All right, so the first 4 problems, those were all reducing fractions. Now, if you'll notice with problem number 5, you'll notice there's 2 fractions there. Well, that's because we're not just reducing the fraction, we're actually going to be multiplying fractions. So in 5 and 6, we're going to be multiplying. 7 and 8, we're going to be adding. Dividing. And then 9 and 10 are we're going to be adding. Well, so let's remember how you even multiply a baby fraction. Again, you don't have to write this down, just kind of giving you a little preview of where we're going. Well, so let's just think about 2/3 times 9 over 10. Right? There's really 2 ways you could do this. You can multiply straight across, so you'd get 18 over 30, and then you would have to reduce it. Or there's a shortcut. A shortcut is that you cross-cancel. What cross-canceling means is you look at the number and you say, okay, well, how many times does 2 go into 10? Well, it goes in 5 times. How many times does 2 go into 2? Well, just once. How many times does 3 go into 9? Well, it goes in 3 times, goes in once. And then what you do is then what is left over, you just multiply straight across. Well, 1 times 3 would be 3, and 1 times 5 would be 5. So that's multiplying just baby fractions. So how would you multiply a funky fraction? Well, the reason why I showed this to you is because it's exactly the same with just one little twist. So 5 goes into 10 2 times, right? So I do the same type of cross-canceling. Now the difference is you see that those are a group. So those have to be factored first before I can cross-cancel. So I'm going to have to do some factoring first, but then I'll be able to cancel away. Alright, so then let's go ahead and take a look at 5.1. And let's be the last problem on the front page, so we're almost halfway there. Alright, so again, these are a group, 7x plus 14 and x plus 2, so they're a part of a group, which means they need to be factored first. So what I would look at is I would say, okay, 7x plus 14 what must have been, there must have been something on the outside that when multiplied would give you that. So again, you ask yourself, well, what do they have in common? Well, there's a 7 that goes into both of them. And then you say, well, 7 times what would give me 7x? Well, that would have to be an x. 7 times what would give me 14? That would have to be a 2. And then I look at the other fraction. By the way, nothing to, 3 is just a number by himself, right? So he's not a part of a group, so there's nothing to factor there. Same thing with 9, not a part of a group, so nothing to factor. I look at x plus 2 and I say, well, okay, it's a group, but they don't have anything in common. Right, because this is just an x, that's just a 2, so nothing in common, so they actually would be just an x plus 2. Now what I look to do is I look to see if I can cross-cancel. Well, just like if it were a baby fraction, 3 goes into 9 3 times. And then if I look the other direction, I see a group of x plus 2. Again, thinking in terms of groups. A group of x plus 2. And then I look to see what's left over. Well, it looks like what's left over is there's a 7 left over, and there's a 3 left over. And I'm going to multiply those two things together. So 7 times 3 would give me 21. And that would be my final answer. So the factoring is a little, the last couple problems got a little heavy there. So factoring on this one's a little bit lighter because we're not just doing it for one fraction, we're doing it for 2. All right, so pause now and try 5.2 and 5.3. All right, so let's see what you got. So 5.2, you should have got 8. And for 5.3, you should have got 20. So hopefully you got 8 and 20 as your answers. If you did not, again, pause. Ask for some help. I know I keep saying that. But what I find, or what I've found so far with these videos, is a lot of times students will just sit through this and not ask for help. Again, the whole point of you being here is to get help. So please, give me the chance to help you if you're having problems with this. All right, otherwise, we will go on to the back. All right, so flip on over to the back. So we're looking at number 6. So more than halfway there. Hang in there. Doing good work so far. All right, so we got two different fractions. And as we said, I see all these plus signs. So these guys are all a part of groups. So that means that everybody needs to be factored first before I can start canceling. So let me just, I'm going to go underneath it. And it doesn't really matter where you start. I just have a tendency to kind of start with the left and work towards the right. So let's start with x squared plus 7x. And again, what I'm doing here is I'm checking for a greatest common factor. That's always the first thing that I'm doing, is before you do anything, right, I'm going to check for a greatest common factor. Well, it looks like they have an x in common, so if I hit the rewind button and I go back in time, then there must have been an x on the outside. And then I say, okay, well, x times what would make x squared? That would have to be x. And then x times what makes 7x? Well, that would have been a 7. And what I meant about, that you can check your work is, what if I accidentally made that a 7x? Which don't write that down because that's not correct. But I want you to see is that if I had done that, I could check my work. Because if I did x times 7x, that would be 7x squared. And then I'm like, oh, but wait, I just need 7x. So I had one too many x's there. So I just want you to see that that's factoring is you could always check your answer. That's what's nice about factoring. X plus 4, nothing in common. Sometimes they're nice to us. Sometimes they give us a problem where we don't have to do any factoring on it. So great, thanks. X squared minus 16. So that is a difference of squares, similar to, actually, I think exactly like one that we had seen in a previous problem. So remember, the difference of squares is what happens there is that the middle number, the b, is missing. It's equal to 0. So you're looking for two numbers that multiply to a negative 16 that add up to 0, which would be plus 4 and minus 4. So x plus 4 and then x minus 4. And then on the bottom, I've got x squared plus 3x minus 28. So I'm looking for two numbers that multiply to negative 28 that add up to positive 3. Let's see, 28, I'm thinking 7 and 4. And you know what? 7 minus 4 is 3. So that checks out. So let's see, x plus 7 and x minus 4. And right now's the fun part. This is the easy part. Now we can just get the nails out and start slashing away here. So x plus 7, x plus 7. I can cancel an x plus 4 and an x plus 4. And I know a moment ago we called this cross canceling. And when we think of cross, we're thinking of diagonally, which is true. But you can also cancel vertically. So for instance, x minus 4, we can cancel an x minus 4 with an x minus 4. The only thing we can't do is we can't cancel two things that are side by side, because if they're side by side, that means they're being multiplied, right? So when we're canceling something, what we're saying is that we're dividing, and that can only take place if they're on opposite sides of the bar there. Well, it looks like the only thing that's left over is just that little x right there, and so that means that that would be our answer. I know it's kind of hard to think that all of that would simplify down to just x, but it did. Also, another thing too I mentioned to you is you notice I circled the x there. I make this mistake, you write all this stuff out and you're slashing stuff, maybe it gets a little messy. So I think it's not a bad idea to go back and circle whatever's left over just to make sure that you don't overlook anything. Alright, so go ahead and pause now and try 6.2 and 6.3. Alright, you might have noticed a pattern. The answer to 6.2 was x, or is x. And the answer to 6.3 is also x, right? So kind of similar problem there, just the factoring was a little bit different. All right, so again, if you weren't sure, see if you can figure it out. If not, let's move on to number 7. All right, now number 7 and 8, and again, you don't have to write this down, just kind of setting this up for you. 7 and 8, we're going to look at dividing fractions. So on each one of these things, what I want to do is, before we actually get into the problem, I want to take a step back and say, okay, let's get back in the time machine, go back to elementary school, middle school, wherever you first learned how to work with fractions, hopefully elementary school, and say, well, how do you just even divide baby fractions? Well, so there's a couple different ways of remembering this, but divisions of fractions are really multiplying by the inverse, right? So what we mean by that, and people got different ways of saying this. Some people say keep, change, change. Some people say copy, dot, flip. All right, copy, dot, flip. All that means is that when you're dividing fractions, what you're really doing is multiplying by the reciprocal. The first fraction stays the same, so it would be 1 over 2. The dot, meaning that the division turns into multiplication. Flip, meaning that we're going to take the reciprocal. So 3 over 4 would turn into 4 over 3. Once you have it rewritten as a multiplication problem, then it becomes exactly like what we just did. So really, it's the same thing, you just have to rewrite it first, right? So for instance, on this, now I just would cross cancel, and I'd get 2 over 3. Well, so it's going to end up being the same thing for this funky fraction. I'm going to need to rewrite this, and then I'll be in a position to cross cancel. Right. All right, so let's see what it would be for this funky fraction here. So let's take a look at 7.1. So as we said, the first thing that we want to do is we want to rewrite this. We want to rewrite this, and this is true for every fraction, whether it's baby fraction, funky fraction, or whoever knows what else other kind of fraction. But we want to change this to multiplication. So again, the first fraction, the copy part, just means the first fraction always stays the same. Change that to multiplication. And then the second fraction, we're going to flip over here. Everything stays the same. We're just taking the reciprocal. All right, I don't see any plus or minus signs, so that tells me that these guys are not a part of a group. If they're not a part of a group, then that means that I don't need to do any factoring. So what that means is that I can just go ahead and start canceling right away. Where do you start? You know, it doesn't really make a difference. Just pick somewhere to start. Let's start with the numbers, though. the coefficients, the numbers in front. We'll get to the exponents in a second. So let's say 6 goes into 12 2 times. And I'll warn you, this is going to get a little messy, even for me. I got to be careful with my own handwriting. So what I want to do is that I'm going to slash it out, and then whatever's left over, I'm going to write that number above it. So that way I kind of keep track of everything. And then 6 divided by 6 would just be 1. 7 does not go into 23, so there's nothing I can do with that. Let's talk about the variables here. A4 into A9. So remember what we're doing with this is that we're going to subtract the exponents. So what I would say is I would say 9 minus 4, which would be 5. And remember, we said that the leftovers go to the side that has more. Right? This is what we said. Go back over here on the right side, right? The leftover variables go to the side that has more. So 9 minus 4 is 5. And there's more a's on the top, so that's where the leftover a's will go. Let's talk about the b's. So I take 2 b's away from b7. 7 minus 2 would be 5. Let's look the other direction. So if we said take 2 x's away from 6, then what would be left over would be 4. And finally, if we took a y away from y4, then what would be left over would be a y3. Now this is what I mean about, especially with me using all this color, it can be a little distracting. I used the color because I wanted you to see what matched up with what. But in the end of all of this, it can look a little messy. So one thing that's not a bad idea is I'll go through there with a highlighter and I'll highlight the things that are left over. So it looks like we got a 7 left over, an x to the 4th, we got a 2, a to the 5th, b to the 5th, 23, and then y cubed. Like I said, it can be kind of difficult to see what all is left over there. As far as the order doesn't really matter. So you do need to multiply though, right? 7 times 2, which would be 14, right? I multiplied 7 times 2. And then I'm just going to put this in alphabetical order, so I'm going to put the a first and the x second, but again, the order doesn't really matter. In terms of numbers down here on the bottom, the only number we got left over is 23. And then in terms of variables, we got a b5, and we got a y3. Let me fix that 5 real quick. And that will be our final answer. Okay. All right, so pause now and see what you can do with 7.2 and 7.3. All right, so let's check it out. 7.2 should have 14a cubed over 13b x squared y. And for 7.3, 6a to the 8th b x to the 4th, 17y to the 6th. All right, so if you need to check on that, pause it here if you made any mistake with 7.2 or 7.3. And then if not, we will march one problem closer to the finish line. So 8.1, so we got another division problem. So we're going to do our keep, change, flip, copy, dot, flip, whatever you want to say. And so what we're going to say is that that first fraction will stay the same. We're going to change that to multiplication. So let's rewrite it first. Keeping this one the same, x squared plus 6x plus 9 over x plus 7. And times x squared minus 49 over 5x plus 15. All right, so you see the plus signs are back. So this tells you it's groups. So this means that I cannot do this. I can't say, oh, I'm going to cancel an x with an x squared, right? Again, and the reason why I keep mentioning that is that so many people make that mistake. So because that mistake gets made so commonly, that's why we point that mistake out there to you. All right, and let's get the rest of this cleared out. All right, so yeah, again, I keep mentioning that just because it's such a mistake that, that so many people make. All right, so it's a group. We know we got to factor first. A group of 3, 1, 2, 3, which we know is a trinomial. Then we know that that's something that has to be factored by using our big X. You know, so I can kind of go to the side and just do a little scratch work here. I'm looking for 2 numbers that multiply to 9 that add up to 6. Well, I'm thinking 3 and 3. And then I'll just come right underneath it. So let's see. We'll have x plus 3 times x plus 3. The bottom part of the fraction, x plus 7, there's actually nothing you can do with that. So that's kind of nice. Didn't have to do anything there. X squared minus 49. That's another one of those difference of squares. So remember, with difference of squares, we're talking about a situation where the b is equal to 0, so that's why there's only 2. So this is that one exception to it. So I'm looking for 2 numbers that multiply to negative 49 that add up to 0. Remember, the shortcut here is it's always, and again, one of the reasons why we call it difference of squares is that the factors are the square root of that number. So you'd have a positive 7 and a negative 7. So I'd have x plus 7 and x minus 7. And on the bottom, 5x plus 15. Let's hit the rewind button. Go back in time before it was 5x plus 15. It looked like something else. So you say, well, what do they have in common? Well, they would have they got a 5 in common. 5 times what makes 5x? Well, that would have to be an x. 5 times what makes 15? Well, that would have to be a 3. And then what we're looking for here is we're looking to cancel. The whole point, and I probably should have made this point a little more clear from the very beginning, but the whole point of what we're doing here is to cancel groups. So if you get to the very end, you get down here and there's nothing that cancels, you made a mistake, right? So, and it's not to say that everything's going to cancel, but you should at least have something that cancels, which we do here, x plus 7 and x plus 7. X plus 3 and an x plus 3. And it looks like that's all that's left over. I'm just going to highlight what I've got left over. Looks like I've got an x plus 3 left over, got a 5, and an x minus 7. So let's put all that back together. So I would have x plus 3 times x minus 7 over 5. And that would be my final answer. You know, you might wonder about, do I need to multiply x plus 3 times x minus 7? You know, for our purposes here, you can just leave it like that. You know, you might see it, on the CST, something like that. You might see it where they'd write it out this way, where they actually multiplied out the 2 binomials on the top. But like I said, for our purposes here, we'll just keep it like that. We'll just keep it in its factored form. All right, so go ahead and pause now, and let's see what you get with the one in the middle and one on the right side. All right, so for 8.2, should have got x plus 5 times x minus 4 over 3. And pause it there if that's not what you got. But if you did get that, let's take a look at 8.3. Should have got x plus 6 times x minus 5 over 4. All right, 2 left. On to number 9. So number 9 and 10, we both look at adding fractions. So we've gone through, we started this study guide looking at reducing fractions. We moved on to multiplying fractions, dividing fractions, and then finally we end up with the last operation with fractions, which would be adding and subtracting. So as I said, we'll go back. Let's go back to elementary school and see if you remember how to even add a baby fraction. Hopefully, the main thing you remember about fractions is you have to have a common denominator, right? The number on the bottom. Numerator is what we call the number on the top. Denominator is the number we call on the bottom. So the denominators have to be the same. And as long as you do have denominators the same, which we do here, then you just add the top. So 1 plus 3 would be 4. And then the denominator stays the same. So that would be 2. And then you just see if you can reduce it from there. Well, 4 divided by 2 would be just 2. So what we're going to do with a funky fraction, it's kind of the same thing. N plus 3n would be 4n over 2n, and then you reduce, right, which would be 2. So it's kind of the same idea. It's just, again, we're doing it with numbers and variables this time, not just numbers itself. All right, so let's look at 9.1. You'll probably end up thinking this is the easiest question on the whole study guide, so it's kind of nice. You know, towards the end you think it's going to be the hardest question, but this one's actually kind of nice. I think this will be our shortest and easiest one. So common denominators, check. Add the top, because that's really, by the way, I didn't write this in there. Right, that's really 1y. If you don't see the number in front, it's really a 1. So 1 plus 9 would be 10. Denominator stays the same. And then what happens is y's cancel each other out. 5 goes into 10 2 times. Or another way you could think of that is just, 10 divided by 5. Either way, you get an answer of 2. And that's it. I know that probably seems like there should be more to it, but if they have common denominators already, then 90% of the work's been done for you. It's when they don't have common denominators that you're going to have to do a little more, which is actually what we'll do in number 10. But let's stick with number 9, so see what you get with 9.2 and 9.3. Alright, so 9.2 should have got 3 for your answer, and for 9.3 should have got 4. Again, if you struggled with either one of those, pause it, see if you can figure it out. If not, ask me. If not, we will move on to the last question. Alright, so the last question, number 10, this deals with adding fractions that do not have a common denominator. So this is where it's a little bit different. If you remember with trying to come up with a common denominator, you ask yourself, is there anything that I can multiply the smaller number by, which in this case is 4, to make the larger number, which in this case is 5? Well, nothing I can multiply 4 by to make 5, but one thing that I can do, and this always works when you're looking for a common denominator, is that if you just multiply the two numbers together, right? So if you multiply these two numbers together, then that will give you a common denominator. So if you multiply 4 and 5 together, you'll get a common denominator of 20. And then, what you multiplied one by, you have to multiply the other. So for instance, we multiplied this by 4, so we'd have to multiply that by 4. We multiplied this by 5, so we have to multiply the other by 5. Right? And then we can add them up from there. And then it becomes exactly like what we just did. So this one is going to work very similar. It's just it's going to look a little funkier. That's why we call them funky fractions. The note that I put here is that we're going to multiply, if you look down here towards the bottom, we're going to multiply each numerator by the other denominator. Right? So what's going to end up happening is that we're going to multiply the two denominators to come up with a common denominator. And so what this will look like is that I'm going to multiply, because see, and let me kind of back up and maybe say one more thing, is that, again, the whole idea of a common denominator, you think if they're common, it means they're the same, right? So if I want these two to look the same, well then they need to have what the other one has. So what I mean by that is that if you want them to be the same, well, z plus 4 needs a z minus 6 so they can both look the same. In the same way, z minus 6 needs a z plus 4 so they can look the same. So you kind of think of it as, okay, what has the other guy got? And then that's what I need so that they'll look the same, right? So z plus 4 and z minus 6. Now, so since I multiplied this one by z minus 6, because what was missing, right, what he was missing was the z minus 6. So I multiplied this by z minus 6, but then what I do to one, I have to do the other. So I have to also multiply that by z minus 6. And then kind of in the same way, what z minus 6 was missing was the z plus 4, so I had to multiply that by z plus 4. And then, of course, what I do to the bottom, I have to do the top as well. So really what we're going to be doing here is that we're just going to be distributing. So I'm going to distribute 6z times z, which would be 6z squared plus 24z. And then on the first fraction that I have over here, I'm multiplying 2z times negative 6 and then 2z times z. So that would be 2z squared minus 12z. Alright, now, yeah, I know it looks a little different than, fractions of what we're used to seeing. What I would do, though, is I would almost kind of think of this, when you're combining fractions, you're almost kind of thinking of it as one big fraction. So what I'm going to do is I'm just going to take everything that's on the top here, 2z squared minus 12z plus 6z squared plus 24z. So what I'm doing here is I'm just kind of making this thing one big fraction. And then z plus 4, because the denominator stays the same. And then what I'm looking to do is I'm looking to combine like terms. So what I notice is that I can combine 2z squared with 6z squared to make 8z squared. And then I can combine negative 12z with 24z, and that's a positive 24z. So really what I'm saying there is 24 minus 12, which would be 12z. And then that's over, again, the denominator stays the same, z plus 4 times z minus 6. And then that would be our final answer. And you may notice that the top could actually be factored. You could factor out a 4z of the top, but then you wouldn't be able to reduce it any further, so we're just going to leave our answer that way. And also the denominator, again, you might see that where they multiplied those two things out, but for simplicity purposes, we'll just leave it there. Alright, so go ahead and pause now and try 10.2 and 10.3 in the middle, and you're almost there. Hang in there. Last problem. Alright, so let's see what you got for 10.2. So for 10.2, should have got 8z squared plus 35z over z plus 5 times z plus 4. And because what you should have done is multiplied top and bottom of this one by z plus 5. And then multiply top and bottom of the other by z plus 4. Right, so hopefully that's what you did. And then for 10.3, should have got 9z squared minus 9z over z plus 1 times z minus 2. Alright, well that finishes it. Really appreciate you hanging in there. Good work. Hopefully you have a better feel for how to work with these fractions, how to simplify them, multiply them, divide them. Like I said, really proud of you for hanging in there, and just proud of you for being here today, right? Making the decision to do something about your grade and get your grade up. So, you put in the time here after school to come in, and it's really appreciated, and I think it's going to be worth it when you see that grade go up. All right, well, we're done with the video portion of it now. Study guide should be complete. So now that you have your completed study guide, just bring it up to me, and I will exchange it for the retake test. Again, thanks again for being here, and we'll see you next time.